Transformers. Okay. We lovingly refer to these things as a 300 watt, a 600 watt, 150 watt. Really though, transformers are rated in voltamperes. And when you're sizing your system, the VA, or the voltamperes of the lights, matching up with the VA capabilities of the transformer. That's what's important. It's not watts, it's truly VA. So a lot of people will refer to VAs as watts, but we really need to understand that there is a difference. So when we're sizing systems, we need to look at the VA rating of the lights, the VA rating of the transformer. As I said, they're often referred to in watts. We have single taps. A single tap where you can hook up wires, it's going to have one breaker in there. We have multi-tap where we have different voltages available on some of them. If we're working with the LED lights, we're always going to ask you, let's always use the highest voltage tap. The reason we want to use the highest voltage tap is because it amounts to the smallest current draw from the transformer. And when you reduce current draw for a light, it helps with other things such as voltage drop across the wiring in the system. We also deal with multiple circuits. 600 watt, 600 VA transformer. They have two circuits. 900 has 3, 1200 has 4. Each of the individual circuits are limited to 300 VA. That's not our choice, that's UL's choice. They want a limited amount of energy available in each of these sections. It's a safety concern. Controls. I've talked about controls and lighting for a lot of time. You know, there's different concepts on those, different value propositions. Some do it for energy savings, some do it for other. But controls have begun to get a life of their own. So we have to start talking about controls. The expectation of the customer is that we have some ability to control things. Controls can be as simple as a photocell, a timer. They can turn on the lights. They can also turn off the lights. And in some cases, they can dim the lights. Our present lights under certain circumstances can be dimmed by some of these control systems. Moving forward in the future, I expect to see greater capabilities at Garden Light in that area. The different types of controls, we have timers. We have what we call digital timers, which you just push buttons and set values in. There's electromechanical timers that are just a little motor that spins a wheel and you got little tabs you push in or pull out to turn them on. The photocells, it's another timer. Both another means of control. Both of these devices here work off of the high voltage that comes into the transformer. It either turns on or turns off the voltage from that goes into the transformer. And control systems, and there's a variety of control systems out there. Some of them affect what occurs on the high voltage end. We can do phase cut on the AC power. It'll transfer through the transformer to the luminaires. Our current systems that will dim utilize those phase cut type systems. There's also control systems that some people make that have LED drivers built into the system, or it's an option in the system. They have constant current reduction is one of the more popular ones. We make a special variety of lights that will interface to those systems. For people who have an existing system, maybe they have a Crestron system, a Lutron system, some kind of Savant system. Control4 is another one. All these people, if their whole home is automated with that, you're going to be wanting to look for a solution that plays off their existing technology. You know, I mean, the days of carrying around 2 remote controls for doing things are kind of gone. So we need to learn to play with the big players in the control system area. The wiring. Okay, this may seem silly, but the gauge size is important. And for many of you, you're looking at, okay, what's the smallest gauge wire I can run and achieve the necessary voltage at the end of the run? Well, that's one aspect of it. But there are other aspects because of the way the LED drivers work. If you get more voltage at the end of the run than the minimum, your current draw is going to be less. And if your current draw is less, your voltage drop across the wire is going to be less. The voltage drop across the wire is a system loss. It doesn't produce light, it just consumes power. So if people are very interested in energy conservation, a bigger wire gauge will actually give that to you. You experience less of a drop. The current draw from the luminaires goes down. Your system is more robust. As I said, the gauge, it affects voltage drop. What most people, in the case of like a halogen bulb, where you're drawing more of a constant current, that's all you're talking about. You're just talking about voltage drop. But in the case of an LED system, where the driver is truly a power converter, and it takes the available power and converts it into the power necessary. Power is voltage times current. So if it's got a low voltage, the current draw has to go up to produce the amount of power necessary at the output. So with LEDs, it's kind of a double whammy versus the days of halogen. So there's more to be gained than just the minimum voltage. There's system efficiencies. Corrosion-free wire improves reliability. We carry a long warranty. One of the weakest links in the system is the wiring, and more specifically, not the wiring, but where the electrical connections are made and how they're made. Those are typically the things that are going to fail first in the field. So by using a wire that's corrosion-free, it helps to mitigate a lot of those problems, extend the life of the connections. It makes a more reliable system. Translation, fewer service calls, so that's always a good thing. Connections matter. A poor connection is just like running too small a wire. It'll produce a voltage drop across it. It's a system loss. In the case of a really bad connection, you may draw enough current that connection gets hot. I'm sure many of you have seen installations where things have been wire nutted and the wire nut is just simply melted when you see it. That's because there was a poor connection. There was resistance in that connection. And when you run current through resistance, it creates heat. So that's a good indication that there has been a bad connection made there. A bad connection on an LED system will drop the voltage to the driver when the driver is going to say, give me more current. And that more current is going to cause the voltage drop to get greater across that, which makes it want to draw more current. And that connection gets hotter and hotter. So connections really do matter. When it comes to connections, there's nothing better than a solder joint. At the end of the day, soldering the joint, you combine the metals, it's surrounded in metals, you can't get any air into it. It's the longest lasting connection you can get. However, it is somewhat time consuming to solder connections. So what's really important is that we get a gas tight connection. It improves the reliability. And by gas tight, what I'm talking about is the wires in the connection. If you're tying into a luminaire at that point, the wires are compressed so tightly that wires are compressed so tightly that we can't get oxygen in between the wires. A good heavy-duty crimp with a proper crimp tool can create a gas-tight connection between the individual strands of the wire. The importance of the gas tightness is that oxygen can't get in there. Without the oxygen, the corrosion doesn't occur. Most of you know what the corrosion is, but if you haven't, go to an installation that's run bare copper wire. Come back 6 months later, strip back the jacket on there. You'll see a black tarnish on that wire. That's corrosion, and that's the oxygen starting to eat away at the copper. When you get that into a connection, that black tarnish starts getting inside the connection and reducing the conductivity. Once again, it creates a voltage drop. Voltage drop causes the driver to draw more current. Voltage drop becomes greater. We create heat. So wiring is really important, but the connections on the wiring will kind of make or break the installation and the length of time that the installation is going to remain in good working order.